Right, guys, so I think I am now live on YouTube. Apologies for the delay in the session. This is why I didn't want to give a time, because I don't know if my sessions are going to run over, and art ran over. So I am now just finished art. We've had a fantastic art session today. So we're going to be looking at today's session on YouTube is going to be about science. So I'm going to be sharing my table again in a second, and then you'll be able to see what I'm doing on my table. So we're going to be looking at the Big Bang. So today's topic, Big Bang. Last week we looked at states of matter. Today we're going to look at the Big Bang. So what is the Big Bang? So for a long time, scientists thought that the universe was completely constant. It was always the same. It always existed. Earth was always the same. The sun was always the same. The universe was always the same. And then there came some research and some discoveries which made them realize that actually there was a Big Bang. So we're going to be looking at the Big Bang Theory today and what evidence there is out there that supports it. So I'm going to share with you what I'm going to be doing on my table here. So I've got an A4 piece of paper, and I'm going to be showing you what's happening or what happens over time to get to where we are now. Okay, so the Big Bang Theory says that we all started off in a little small tiny little pinhead. So if I were to take the pin out of my headscarf, that's how small everything was compressed into. Okay, so the thought is everything was compressed into that small, tiny little bit. Let me check if you guys are online and if you guys are watching. Yes, we've got some people. If you are watching right now, give me a shout out. I know I'm a bit late to starting. Right, so what I'm going to be doing is I'm going to use some colors to show what's happening. So we're going to start off with, where's my pen? Let's get some colors over here. So first of all, we're going to have a Big Bang over here. So we're going to start off with, that pen does not work, a Big Bang. Okay, so everything starts off as a small little pinhead. We're going to explain how the universe started. So it started off as a small little pinhead. There was a big explosion, and we don't know what caused the explosion. So we can't even go that far behind to actually understand how the explosion started. But I want you to be creating the timeline of the Big Bang on your sheets of paper and submitting those in to include in the video. So in the corner, write your name. So my name's Sid. I'm also going to be writing Science with Sid at the corner. Okay, so remember to write that in. You can also write the date if you want. And your submissions need to be in by 6 p.m. today. Okay, so either you send them to workshops@femtinos.com, or you can WhatsApp them to me or Facebook message them to me, and I will include those in. Okay, so what we're going to be looking at is the start of the explosion. We've got the Big Bang. And in the first few seconds, something happened. I want you to create a funnel. So we're going to go, woo. We're going to have a funnel over here. Woo. I can feel rubbings at the bottom because I've been rubbing out in art. So here, we've got our funnel. Okay, so this is representing that the Big Bang started off as a small little compressed ball. It was so tiny. All the mass and everything, all the elements were in this little small piece. Okay, then what we've got, first few seconds, we're going to divide this up. This is the first few seconds. So I'm going to write here, first few seconds. First few seconds. What happened in the first few seconds when the Big Bang exploded? Well, in the first few seconds, all we had were particles. Little subatomic particles. They were so tiny. These aren't even atoms yet. These are subatomic particles. They're smaller than atoms. So we're talking about electrons. We're talking about protons. We're talking about neutrons. For those of you who have done periodic table with me or have done electricity, you will know what an atom looks like. These are the little bits that are inside atoms. Okay? So these were the subatomic particles that we had. So I could write over here, subatomic particles. Okay, so these are little electrons whizzing about. There wasn't anything there. There weren't any elements at that point. There wasn't anything else. So this was in the first few seconds when the explosion happened. What happens next? So we're going to go up the timeline. What's going to happen next? Right, and then over a period of time, and this took a very long time. So this took 380,000 years later, we had atoms. Okay, what are atoms? Atoms are everything around us is made up of. So if you think about Lego, you can put Lego pieces together. Now, I don't have any Lego pieces here, but imagine I've got Lego pieces in my hands and I'm putting them together and I'm making stuff. I can make cars, I can make houses, I can make people out of Lego. But all of those Lego pieces are different sizes, they're different colors, and they're different dimensions. Okay, but when you piece them together, you get all of these different things. And atoms are a bit like that. When you put atoms together, you get different materials. You get the paper, you get my hand, you get the table, you get the sky. Everything's made up of atoms. So what we're going to be doing now is drawing some of these atoms. So atoms have neutrons and protons in the middle, and then they have electrons whizzing about. Now, you might have seen this design of an atom drawn on lots of different things. It's on our lab coats, it's in lots of symbols that you will see an atomic structure to be like this. That's not what a real atom looks like. This is just a model. In chemistry, we tend to use shells instead to represent where the electrons are. But this is a nice diagram just to represent an atom. So I'm going to draw another one over here. 4, 5, 6, 7, 8. Because I've drawn 8 little bits on the inside, I'm going to draw 4 electrons. And what we know is you've got the same number of protons as you do electrons. So if we have 3 protons in the middle, you're going to have 3 electrons on the outside. If you've got 4 protons in the middle, you're going to have 4 electrons on the outside. And you've also got neutrons, which glue everything together. Okay, so this is subatomic particles in the first few seconds. 380,000 years later, we had atoms. Okay, so atoms started to form, and you would have the smaller atoms form. So atoms like hydrogen, atoms like helium. So hydrogen is the most abundant element in the entire universe because it's the smallest atom. So with hydrogen, you only have 1 proton and you have 1 electron. That's hydrogen. Okay, so this over here is hydrogen. It's the smallest atom in the entire universe, and there's loads and loads of it in the universe because it's so tiny that you can have, this is the first thing to form. On Earth, we had loads of hydrogen, but over time, it started to run out, and we find hydrogen underground, and we use it in lots of different things, and it's starting to run out, and helium as well. Helium is starting to run out as well. So we've got, first few seconds, subatomic particles. 380,000 years later, we have atoms. Okay, so we're talking about the Big Bang here. So I'm going to write here, Big Bang. So at the moment, scientists believe this is how the universe started. They don't know what created the Big Bang, what created that explosion that got everything to be working the way it is. We don't know what caused the Big Bang, but we know, well, scientists think, that if they go back in time, that we started off as a really small, tiny dot, okay, smaller than a pinhead. Then the first few seconds after the explosion, we had subatomic particles. So these are little electrons and protons and neutrons. 380,000 years later, we had atoms being formed, and the smallest atoms would form first. So hydrogen was the atom that's the most abundant in the universe. What happened next? Picked up the wrong pen. Right, next. This is going to be 300 million years later. 300 million years later, we started to have the formation of galaxies. Let me see if I can make that better. Lighting. So we had the formation of galaxies. So I'm going to draw here galaxies. And for those of you who have done space with us, we know that there's around 4 different types of galaxies. We've got the spiral galaxy, we've got the elliptical galaxy, we've got the spiral barred galaxy, and we've got the irregular galaxy. And all of them have a general different shape. So here I've drawn a spiral galaxy. Okay, so you can draw different types of galaxies there, and sideways they will look something like this. So we've drawn lots of different galaxies. So we have galaxies are formed here. So remember, we are in a galaxy as well. We are in the Milky Way galaxy. How cool is that? So our galaxy is called the Milky Way. So we've got first few seconds, subatomic particles. 380,000 years later, we have atoms. 300 million years later, we have the formation of galaxies. Right, let's have a look at where we came into being and where our planet came into being. So I'm just going to stretch that funnel out. Now, 9 billion years later, I'm going to write here 9 billion years later, we now had the formation of the sun. So we've got sun, we're going to have Earth, we're going to have planets over here now. So I'm going to draw Saturn. I think you can color this in. So I want you to submit your drawings. We're going to have planet Earth. Okay, so here we're going to have planets and stars. So I can draw a little star in the background there, a little star over here, little star over here. So lots of people did the space course with us, and we went through this in a lot more detail. But let's start again from the beginning and have a look at the Big Bang formation. So the Big Bang theory is our current theory. The evidence supports this. When new evidence emerges, it might change, but we've got quite a lot of evidence to suggest that this is how it happened. Now, we don't know how the Big Bang started, but there was an explosion. And within that explosion, the universe started. First few seconds, subatomic particles. 380,000 years later, we had atoms being formed. 300 million years later, we had the formation of galaxies. 9 billion years later, we had planets and stars being formed, and our own planet started to be formed, okay? So remember, these planets and stars are within the galaxy. These galaxies contain lots of atoms. These atoms contain the subatomic particles. So this is just a nice visual way of seeing how the Big Bang has formed over millions and millions and billions of years. Right, guys, so I want you to submit your Big Bang drawings to me to show me what yours are going to look like. So I'm just going to move that back so you can see the entire image there. Okay, so this is what a rough drawing of the timeline of the Big Bang looks like. So I want you to submit your drawings, write your name, write Science with Sid, submit them and color them in. So I'm going to be coloring mine in to make it look nice and colorful. What you could go away and do some research on what theory existed before the Big Bang. And if you can find the evidence, there's about 2 or 3 bits of evidence that science has come up with that proves that supports the Big Bang theory. Can you find that evidence and tell me in the comment section what that evidence is? And it's some really cool evidence, and you can use everyday scenarios to help you explain some of those things. Okay, guys, thank you for watching. This has been a short YouTube video just to show you what you could be doing at home. You could be creating this lovely Big Bang funnel, the different stages of the Big Bang. Color it in, submit your entries by 6 p.m. and then I'll be sharing them today at 6 p.m. Submit them and I'll create a video for you guys, okay? So let me know how you found this. This is a nice drawing and I look forward to seeing your finished images. I'll see you guys soon. Bye. I don't know how to stop the live again. I always get to this point and I don't know how to stop. There we go. Stop live stream. Bye, guys.